For this next example, we've got given cos theta plus I sine theta to the power of 3. It says find cos 3 theta, sine 3 theta, tan 3 theta. That's part A. B says solve x cubed plus 3x squared minus 3x minus 1 equals to 0, given that x equals to tan theta. And then the last part is show that tan pi on 12 times tan 5 pi on 12 equals to 1. So we'll start with part A. Before we do anything here, let's just go with what the question's given us. So they've given us this. So this is basically the same thing that like DeMoivre's theorem says. Cos theta plus I sine theta to the power of 3, or cubed in this case, equals to cos 3 theta plus I sine 3 theta. So this is what this equals to. Now we can use binomial expansion to expand this. So binomial expansion, but extension 1 maths, we can go 3c0 cos cubed plus, that's just to the power of 0, that just doesn't exist, which is just 1. 3c0 cos cubed, actually sorry, I'll just do this, slide this over so that we have space. I'll just slide this over here, so we've got 0, so we can go 3c0 cos cubed theta plus 3c1, we go cos squared theta, we go I sine theta plus 3c2, we go cos theta I squared sine squared theta, bringing this down here, plus 3c3, that's just becomes 1, and that becomes I cubed sine cubed theta. So this is what this equals to. Now we can clean this up. So 3c0 gives me, I think it's just 1, 3c0 is 1, so we go 1, which is just cos cubed theta, plus 3c1 is 3, plus 3 I squared is negative, so this then becomes imaginary, so we'll just write it down. So we go cos squared theta 3, we can go I at the front, take I at the front, cos squared theta sine theta, my 3c2 gives me 3 again, so 3c2 would also be 3, but then we've got an I squared here, so I squared then becomes negative 1, so this then becomes minus 3 cos theta sine squared theta, and then I said 3c2 is just 1 per I cubed is going to be I squared is negative 1 multiplied by I, so negative I, that then becomes negative I, so minus I sine cubed theta. So if we solve this up again, we can bring out the real parts and the imaginary parts together. So the real part then becomes cos cubed theta minus 3 sine squared theta cos theta. That's the real part. And then we get the imaginary part, which will be, wait, did I make a mistake in I cubed? So I squared is negative 1 multiplied by I, which is negative I. Negative I sine cubed theta. So we can factor out I here, and we can just put the negative. So this then becomes plus I brackets, same thing, 3 cos squared theta sine theta minus sine cubed theta. Sine cubed theta. So that's your answer with the expansion, but from here we can easily just solve cos 3 theta and sine 3 theta. I'll tell you how. So if this equals to this, so the real part of the expansion of this gives me cos 3 theta. So therefore cos 3 theta then equals to, use another color, so cos 3 theta then equals to this, and sine 3 theta then equals to all of this. So that's sine 3 theta. So we can write that down as cos 3 theta, so this then equals to cos cubed theta minus 3 sine squared theta cos theta. So that's the answer for cos 3 theta. And then sine 3 theta then equals to this value over here, which is 3 cos squared theta sine theta minus sine cubed theta minus sine cubed theta. So that is the value of cos 3 theta and sine 3 theta, these two answers. Tan 3 theta is a little bit different. I'll rub this side of the board just so that we get an understanding. Or I'll just solve it over here. It's alright, I'll just solve it over here. So we've got tan 3 theta. Tan 3 theta equals to sine 3 theta upon cos 3 theta. Correct? So tan is sine upon cos. So sine 3 theta upon cos 3 theta. So we can just put these two values, this and that together. So I'll just do it down here. So we got sine 3 theta. So this then equals to sine 3 theta is 3 cos squared theta sine theta minus sine cubed theta all upon cos 3 theta, which is cos cubed theta minus 3 sine squared theta cos theta. Right? So the next step we can do from here, if we want to further simplify this, is if we multiply top and bottom by, if we divide top and bottom by cos cubed theta. So that just cancels out that. So let's just divide top and bottom by cos cubed theta. So divide both sides by cos cubed theta upon cos cubed theta. So I'll bring this over. So divide both sides. So this then becomes that becomes tan cubed theta. Divide both sides by the cos squared 1 upon, so that's sec theta, and then sine upon sec squared theta. So we have 3 1 upon cos is cosec. Sorry, 1 upon cos is sec, and 1 upon be tan. Or am I making a mistake? So if I divide both sides, so this then becomes tan 3 tan theta cos, and then cos squared upon cos squared is just, and then cos squared will cancel out. 3 tan theta minus sine cubed theta upon cos cubed theta is tan cubed theta all upon 3 tan theta minus tan cubed theta upon, if we divide that, that just becomes 1 sine squared, cos and cos get cancelled out, minus 3 tan squared theta. Okay, so this then come back to tan 3 theta, which then gives us this solution right here. So let's just write that down. We've got tan 3 theta equals to 3 tan theta minus tan cubed theta all upon 1 minus 3 tan squared theta. 3 tan squared theta. So now we look at this equation here. So it says solve x cubed plus 3x squared minus 3x minus 1 equals to 0 given x equals to tan theta. So I'll rub out this side of the board so we have more space. Okay, so we look at this. Put this blue marker right here. Well, x cubed. So we have x cubed plus 3x squared minus 3x minus 1 equals to 0. And it says use x equals to tan theta. So let's just sub that in. So we get tan cubed theta plus 3 tan squared theta minus 3 tan theta minus 1 equals to 0. So we have that. If we come back to this, we can add the 1 on the other side and add minus 3 tan squared theta on the other side, which then gives us the denominator, which is promising. So we can go tan cubed theta minus 3 tan theta equals to 1 minus 3 tan squared theta. Now divide both sides by 1 minus 3 tan squared theta. We divide both sides by that. We get tan cubed theta minus 3 tan theta all upon 1 minus 3 tan squared theta, which then equals to 1. This looks very similar to this, but it's not quite there, because this is tan cubed theta minus 3 tan theta, and this is 3 tan theta minus tan cubed theta. So what can we do to this to make it into that? We can times both sides by negative 1. If you times both sides by negative 1, the top then flips and this becomes negative 1. So we can go 3 tan theta minus tan cubed theta all upon 1 minus 3 tan squared theta. The only reason the top changes is because when you multiply by negative 1, it's negative 1 upon 1. So the top can only change, the bottom doesn't change. And then this then equals to negative 1. What does this look familiar to? 3 tan theta, which is equal to tan 3 theta. So we can replace that with tan 3 theta. So we go tan 3 theta equals to negative 1. Okay, it gives me negative 1. But it's still not quite there for me to equate the two separate parts. So what can I change this negative 1 into? What value of tan gives me negative 1? Tan 45 gives me 1. So tan pi on 4 gives me 1. So in this case, change this to tan negative pi on 4. So this then becomes tan 3 theta, which equals to tan negative pi on 4. Tan negative pi on 4. Beautiful. Now we can equate these separate parts. So tan and tan cancel out. Take the inverse of both sides, which then leaves me with, write this down, which then leaves me with 3 theta equals to negative pi upon 4 plus n pi. We've got to use the constant n pi here. From here, okay, I can just write for any integer n. So what we can do here, we can now sub in values for n. So we can go 3 theta equals, so let's just sub in n equals to negative 1. So minus pi on 4, so negative 1 upon 4 minus 1. So we get negative 5 pi on 4. We'll just start with that. So negative 5 pi on 4. We'll sub in n equals to 0. We get negative pi on 4. N equals to 1. We can just add 1 to 1 upon 4. 3 pi on 4. Add 2. We get 7 pi on 4. And we'll go one more, add 3. We get 11 pi on 4. Pi upon 4. So now what we can do is, we can divide 3. So theta then equals to negative 5 pi upon 12. Negative pi upon 12. This then becomes 3, 4, pi upon 4. And this then becomes 7 pi upon 12, and this becomes 11 pi upon 12. So the final answer for this cubic then equals to, we have x then equals to tan theta. So this then becomes tan of negative pi on 12. We've got tan of pi on 4. And we've got tan of 7 pi on 12. These two values here, they just keep repeating and come into these three values. So they're kind of irrelevant at the moment. So these are the three values that suit this equation over here. So these are the final answer for that. So now we can come on to C. So this, to able to solve this, we need to know the polynomials from extension 1 maths. So this is this is product of roots. Product of roots, so we've got alpha, beta, gamma, in this case, equals to negative d upon a. Alpha, beta, gamma equals negative d upon a. So in this case, alpha, beta, gamma, so we have alpha and beta. We need to know what gamma is. Gamma can be negative 1. So we can go, to solve C, we can go tan of what we had here. So negative tan upon pi upon, negative tan pi on 12 multiplied by 1 multiplied by tan, because that and that are interrelated. So tan 7 pi upon 12 is equal to negative tan 5 pi on 12. So we can add the negative here. Sorry, my bad. 5 pi upon 12. So if we know that and that and that, that then equals to negative 1 upon 1, which then equals to 1. So therefore, tan pi upon 12, tan 5 pi upon 12 equals to 1. And that's how you do these questions.